Okay, cool. So I think Tom, during his talk, promoted it quite extensively, actually, and I share the enthusiasm about KEDAHttp. And if I talk about KEDAHttp, I am talking about Aaron. Hey, Aaron, I can't see you.
He's shy.
Nick, where's Aaron? Cool. Hey, Aaron.
Hi.
So nice of you to join us. Yeah, you describe yourself as a Gopher, Kubernetes, and functional programming nerd. You do all things live coding, and you're a cloud advocate at Microsoft. Your Gopher program committee, right?
Yeah.
So, and you figured, hey, well, KEDA, that's kind of cool, but
we wanted to. Tom sold it really well, actually. We wanted to add support for HTTP-based workloads to KEDA, and I'll go into some more detail about it. But he also mentioned this too. It turns out HTTP as a event trigger is a little bit different than some of the other event triggers that KEDA does, and also sort of traditionally event triggers that we're all used to thinking about. So it's been really rewarding to dig into what HTTP as a trigger means. It's kind of like pulling on the thread of a sweater. It keeps unraveling, and there's more and more and more that you discover that not only you need to do, but also that you can compose together. There's a lot of functionality you build once, and then you can kind of compose it together with other parts of the system, and you get that feeling that things kind of just fall into place. It's really nice.
Nice. And it well, recently you reached a milestone, I think. The project moved on GitHub to a new repository.
Yeah, we had built a MVP, maybe an alpha, in a separate repository, and actually, Tom mentioned those developer meetings. I went to the developer meeting. I think I had done one PR in KEDA before that, so I was pretty new to the project. And I pitched it, and the folks there liked the idea, so I wrote a proposal and built the prototype. And I think I had built the prototype before the meeting, actually. So wrote the proposal. We went through a pretty informal, lightweight process to figure out how should this thing look, and should it be split up into different components. And after that point, they were nice enough to make a repository under the KEDA GitHub organization, and here we are. So I am proof that if you want to contribute to KEDA in any way, big or small, you don't have to be a KEDA veteran. You can make big impact close to day one if you want to.
Cool. And it shows how important it is to be a welcoming community, because you get cool stuff like you did. Nick, you are totally invited. You hear it to propose it and get going yourself. Okay. So yes, I would say thank you for joining, Aaron, and share what you got, please.
Sure. Let's share my screen. There we go. So I am assuming you can see these slides. Yeah. Okay. Yeah. So again, thank you for having me. This is where I live on the internet here, Twitter and GitHub. Tom did a really great job, I think, of course, explaining what KEDA is and how it works, but also sort of not only saying doesn't yet support HTTP, but also a little bit about why. So thank you, Tom, for selling my talk and selling this project really well. I really appreciate that. And I appreciate that KEDA exists too, to be the sort of foundation to what I'm talking about today. So yes, KEDA doesn't support HTTP yet. And as I mentioned, and Tom mentioned, it's kind of hard to support HTTP if you think about it as just a trigger. So incoming HTTP events aren't like in event hubs or a RabbitMQ or something like that, because you can't predict at any point in time. You can't predict, say, there are 10 queue messages pending. You can't really do that with HTTP because those are generated from outside of the system. So the question that I've been thinking about for such a long time is not only why is HTTP different, but also why is HTTP important? And that one's a big one for me. I've been thinking about this for a while now, and I've sort of, over the past year, I've had a lot of time to think in 2020, like many of us, being inside all the time. Over the past year, I've noticed this trend, and as has the CNCF, that one of the fastest growing sectors of Kubernetes users is something called an app developer. App developer means a lot of things, but first and foremost, this means that these are folks coming to build on top of Kubernetes, not necessarily to build Kubernetes. And most of the time, what they're building is HTTP apps. And many of those are going to be public, internet-facing HTTP apps. So this combination of people who are building on top of Kubernetes, they may not be interested in learning Kubernetes right away or at all, potentially. And also they're building code that's going to run on the public internet. This all kind of necessitates a different developer experience than what we're used to. So what I'm looking for is, I don't want to tell a new development team to Kubernetes that's building a Node app that they have to build a Helm chart and understand all the components of a Helm chart and get this thing running on Kubernetes. So I want to unlock, and some people say maybe democratize Kubernetes for these type of teams or even indie developers who come to Kubernetes. So I put this slide here, sort of introduce myself a little more, but also that this isn't a new problem to me or really to many people. I think the Kubernetes community has been thinking about this as a whole for a while. And the reason I'm here and the reason that I put that work into the KEDA project to try to add this functionality to it is because I think it's time to have not just KEDA build an HTTP solution, but I think it's time to really spark a lot of innovation in the Kubernetes world, in this space, to really welcome a lot of new developers into the community. So I've been working on this problem for a while. I think the first time that I did anything sort of HTTP platform related on Kubernetes was maybe late 2015, early 2016. I built a platform at an old company that got acquired called KEDAHttp. We built sort of a platform as a service there that was componentized, and there were a few other things since then that have sort of helped me think about the problem to get to here. So I mentioned this already. It's not a traditional trigger. I also mentioned a bit about why, but just to go a little bit further than that, supporting HTTP on Kubernetes is more than just having a pod or even a deployment or a replica set. You have to do more, right? And I think a lot of us know this. If you have a Docker container or any container that's got a process listening on localhost port 8080, That's not really enough to be able to properly route even internal HTTP traffic to that pod. You have to do at least a service, and if you want it to be on the public internet, probably have an ingress controller and then submit an ingress object as well. If you want to take care of SSL, if you have to do more. If you want to take care of having a subdomain, for example, you've got to do a little bit more. And of course, if you want to do scaling, then you need to adopt KEDA. So these are all the reasons why I say it's traditional. It's not traditional. So it's not just about the event-based model of HTTP. There's actually a usability model that is different than if you want to scale based on, let's say, RabbitMQ or event hubs. And so just to illustrate that, if you want to have just an internally routed HTTP service in Kubernetes, you've got to learn a deployment and a service. So not the end of the world, not a lot of work. If you want to expose that to the public internet, though, you've at least got to learn ingress controllers and ingress. And then if you want to start getting a little bit more fancy, like I'll call it, you probably have to learn then how to do deploys. So I call that the rollout strategy. You almost certainly then have to learn how to do SSL. Excuse me. Of course, you got to learn how to do auto scaling. You're going to have to learn how to take care of cold starts. If you're going to be auto scaling down to 0, like Tom mentioned, you can save resources that way. And eventually you're going to have to learn something I call magic, right? So these are the things like, what if your ingress controller isn't working like the docs say it will? You might have to upgrade the version. Or what if the auto scaling behavior changes behind the scenes? Or what about if your SSL certificate expires? Things like that. So it's not to say that the HTTP solution for KEDA is going to solve all these things. But it is to say that running and operating a publicly facing HTTP service, whether it's a web app or a REST API or something else, running that thing in production sustainably over the long term is actually really hard. And there's a lot of gotchas that you hit sort of on the second day or the third week or the 5th month that you might not even know you don't know on day one. And so this is the usability issue that I like to talk about. So then the question is, okay, well, how do we solve it? And where do we draw the line? So going back to here, which of the things in this list are we going to tackle and which are we going to explicitly declare out of scope? So there is a lot of prior art in this world, not just in Kubernetes. It's inside and out of Kubernetes. So we've got things like Heroku, of course, Heroku and Google App Engine, Azure App Services, Amazon Elastic Beanstalk, DigitalOcean App Platform. I've used all of these, and they each have their own pros and cons, but they each solve many or all of those problems I just mentioned in their own way. And it's important to see all of those, I think, because they all draw the line and split up the responsibilities of solving those problems in different ways. But then you also have things inside of Kubernetes. So for example, you've got Knative, which has started to really dig in and figure out how to do the rollouts. They also have figured out how to do some scaling and some routing as well. And as Tom mentioned, Knative and KEDA also can work together as well in some ways. So that is a really important piece of prior art. Of course, we have KEDA as well, which we happen to be building on top of here. But KEDA is great prior art as well for how to do auto scaling. And then there's the horizontal pod autoscaler that KEDA is built on top of too. So then the question is, okay, where do we draw the line? We kind of can figure that out based on prior art. The question then is, okay, well, how do we go about solving this stuff? And we, the people who are kind of behind KEDA HTTP, which includes Tom, some other folks too, and myself, we've sort of put together some principles here that we have used to guide what we built. So for me, the first one with the tree is most important. I think that KEDAHttp is good because it provides a great developer experience. That's what that DX is there. So my test for this system is how easy is it for someone who's never used Kubernetes, who has a Docker container for their app, to get something up and running using this system. So that's the good DX for me. Almost as important, though, is I want to be able to take as much off the shelf as possible rather than building things from scratch. And so KEDA is one of the biggest components, of course, in this system. And to me, it's more important to be able to assemble these things properly in a semi-opinionated way, again, to provide that good developer experience, rather than inventing a whole new suite of projects that have to be not only maintained, but also then a new community has to be built around that, rather than just building on top of the great technology and the great community that KEDA already has. And then finally, something that's getting to be more important these days is how do you build this thing to be able to customize? Because the first day, the person who comes on the first day of their Kubernetes world experience, who develops and deploys using that great DX under the tree, well, in a month, they probably want to get more fancy. They probably want to customize how they do routing, or they might want to move their SSL certificates away or deploy in a different way than, let's say, a CLI, in a different model than, let's say, Helm or something along those lines. So it's really important that from the start, we took this thing and we decided how we were going to componentize it and allowed those components to be customizable. And again, I mentioned this at the beginning, that was a big part of the process of getting this new repository and starting to build out this project inside of the new KEDA repository. So let me show this thing at work. I want to show briefly the developer experience, that first time developer experience under the tree there. And I want to show some of the machinery sort of behind the scenes inside of Kubernetes to sort of give a look of how the DX is being serviced and also how the architecture is put together as well. So I'm going to take the slides off and bring a terminal up. So this top pane here is where I'm going to be working. The bottom pane is the slides server, so you can ignore that. So you're going to be seeing me type some commands up here next to the crab there. And you'll also see this terminal tab is the K9S dashboard for Kubernetes. So you can see here, these are pods in a namespace. Of course, I've got KEDA running. KEDA is pinging a scaled object for an external scaler. And that external scaler lives here in this cscaler-proxy. The proxy has a few other things in it that deal with how to route and predict HTTP traffic. But first and foremost, the majority of that is basically the KEDA external scaler interface. So it implements the external scaler interface, which you can find on the KEDA site. So I'm going to show the developer experience here. I've got this little CLI called CApps, and this is that first day experience. So I basically want to say CApps run and then my app name, XKCD. I'm just running a little server that renders XKCD comics. That was built by it was a cool app built by a coworker of mine. So I want to be able to specify the image, of course, and a port that it runs on. This is the day one developer experience that we give to people. Now, of course, you can get more fancy. Behind the scenes, this is generating a lot of machinery in Kubernetes. A scaled object, a service, an ingress, a deployment. I think that's it. I may be forgetting one or two components, but It at least generates that stuff. And we want to be able to, of course, allow folks to customize any of that. But on day one, and I think this may be good enough for like the first week or maybe even the first month for people, this is that developer experience that all of this behind the scenes is servicing. So let's run that. And let's just go see it running. So there's this little subdomain that you get called XKCD, so the app name. I've got this running under a domain called containerapps.dev because I am not great at naming things. So we've got this and comic, and let's just render a comic number 200 XKCD. So we just get a comment, and these are dynamically generated. So we can go to 201 and kind of prove that. This is actually HTTPS enabled. I just didn't enforce redirects to HTTPS from HTTP. But this kind of goes to show that the basic principles of a public web application are there. The basic features you need are there. And we haven't shown auto scaling yet, of course, so we're going to show that now, sort of the last piece. So I will keep this dashboard open, and you'll see there's the proxy, of course. This is the new pod, XKCD. So this sits behind a deployment, which sits behind a service and an ingress. And there's also a scaled object for it that was automatically created as well. So I'm going to run a little load generator tool, and we'll see how this stuff scales up. So I've got a little load generator called Hey. You pass the total number of requests you want to send to the XKCD server. So I'm going to do 200,000 requests, 2,000 at a time, so 2,000 concurrency. And I can actually, wow, that was the first time I've typed that correctly in a while. So we're going to send 200,000 with concurrency of 2,000. I'll just hit enter there. And we're going to wait just a second for KEDA to pick up the load from the external scaler here. And if the demo gods are smiling on me, we will see this thing scale up. There we go. So you see here, not only is the app scaling, that's down here, but the actual thing that's routing HTTP traffic from the ingress controller. So it goes my little load generator tool to the ingress controller into this proxy so that it can report the metrics, and then down to the actual app. So this thing itself is scaling up automatically with KEDA, and then based on the metrics that it itself reports to KEDA, the actual app is scaling up as well. So the real important piece here is that we were able to get all of this done with a CLI command, right? So all of the background stuff is really nice to have because you can say as the day one developer, I can run this command and I can get the features that this stuff provides. But you might not even necessarily know on day one that you're using KEDA. And that is really the important DX here, is to make all these technologies fade into the background while assuring someone who comes to this system that it's built on good technologies with good communities and good foundational technologies. And you can be sure that when you do need to adapt, when you do need to get more complicated or build some new feature, that the community will be there to help you build it. Or it's on the roadmap even, and you might not even have to build it. Cool. So let me head back to the slides here. We saw the most basic, the most basic interface. And I'm so excited about it because it is so basic. I could have done a cooler demo where I generated a bunch of YAML and submitted a Helm chart and saw some of the deeper features of this thing. But I love to show the simple demo because I love the developer experience. By now, you can probably tell I love developer experiences. So I really love the simplicity of this one. But I think it is important to talk about the extensibility of this thing because I think many of us have seen this if we worked on teams, especially if we've been working with Kubernetes because it moves so fast, that we have needs for our applications that we don't anticipate. We don't know what we don't know, right? So this system is built with that in mind as well. What we're trying to do is let people have a smooth sort of a glide path from the really simple interface that you might use for 2 weeks to a month up to something that's slightly more involved and complex, but exposes more power, all the way up to maybe even the raw HTML in Kubernetes. And so I call that glide path, I sort of just call it an escape hatch, right? So if you are on the CLI, you might get 5 features. You might get to specify secrets, environment variables, a port, an image, and maybe like a routing rule or something like that. And that's it. But once you need to do more, that's where this escape hatch, quote unquote, escape hatch comes from. And that allows you to drop down into a lower level, access more complexity, and access more features. So the second angle on extensibility is new interfaces. So you might not want to do a deploy from a CLI. You might want to do it from the open application model, for example, or from a Helm chart, as another example. And then sort of binding this whole thing together, this whole project together, I already mentioned that we're trying to assemble rather than invent. Well, there are a lot of new important technologies that come on the scene in the CNCF world. And we think it's important that where it makes sense, we provide deeper integrations with those technologies as necessary. So if someone needs to, say, drop into some more complexity and add a service mesh, we believe that we should make it easier rather than harder to drop down from the CLI and access some functionality or features that you need from a service mesh, like Istio or Linkerd or something like that. So a lot of this stuff we have in mind now, and we're starting to do. So for example, we're starting to figure out now, how do we make escape hatches, and how do we make it easy to add new interfaces to the system? We're already thinking about integrations, things like service meshes. And Tom mentioned the SMI work that the KEDA group is doing. But we're starting to think about more things too, beyond just the service mesh. What does it look like when this thing runs with other CNCF technologies as well? All right, so a lot of this is future stuff, but it's sort of just starting to become in progress, if you will, at the beginning of 2021. So plans are, we, of course, I mentioned the repository work is ongoing in there to bring the prototype. I showed you sort of an alpha or prototype, if you will. So we're productionizing that code and bringing it from this repo up into this repo. So if you head over to this HTTP add-on repo, you'll see a huge PR that'll get merged in the next, probably in the next couple of days, maybe the early of next week. And that is sort of in service of getting to a beta by approximately the end of this month. So look out for that. And if you are interested in contributing, of course, we follow the same principles as the KEDA core team as well. So all are welcome. My role and the folks that are working on this right now is to get the prototype code productionized and into here. Continue to kind of figure out the best developer experiences from simple to complex and all along that spectrum. And of course, again, like Tom said, he put it really well, do the boring stuff so that other folks come in and build what they need. So I will leave it at that. This is my address all over the internet. And most importantly, these slides are available on GitHub at that link, a little short link, so you don't have to type a bunch of stuff. bit.ly/contrib.today 2021. So go there anytime. You can see all the slides. It's just Reveal.js slides, so you can run them in any browser. So that is all for me. I guess it's time for questions, I suppose.
Amazing! What a great talk about KEDAHttp. This is so exciting. If you said, hey, this is just first day demo. Let's make it simple because of the developer experience. And now I'm a person, I've been on both sides, on the ops and on the dev side, and I was watching that and thinking about all the stuff I would have to do to implement the same functionality for my application. All the stuff I need to do and not be able to do it right, Even then, stumbling upon very complex matters. And one of the challenges I always experience, it's so hard to keep up with all those little components which you need to use to get basically the same functionality. So it's like it's a 1 minute version of a day's work. And yes, you can automate it, but then again, one of the components gets touched, and KEDA saves a lot of time. But this, of course, is really powerful. So you said, this is like obviously the day one version of it. So, but it is actually quite fine-grained what I can control.
Mm-hmm. Yeah, the CLI experience is meant to be. I would liken it to something like maybe Heroku, that kind of experience, without the build packs. This is more around the lines of you have a container, get it up onto Kubernetes with all the bells and whistles ready to be served on the public internet with a command. But that escape hatch right now that we're looking at, there's kind of a few technologies that might work as sort of one or more of these escape hatches. I think the deepest one, if you will, goes all the way down to probably a Helm chart. And that way, all the stuff, all the things boils down to Kubernetes objects, which are YAML. So if we can let someone go all the way down to a Helm chart, then they can do Helm revisions, but they can also go and tweak any single line of the YAML that they want. But we know the cost of that, of course, right? We know the cost is you now need to learn all of KEDA, all of your ingress controller, deployments, services, pod specs, rollout strategies. I can keep going. All the things that those who have used Kubernetes for a while have felt pain around. And I'll just throw one more thing out. This is not a reflection, a negative reflection on Kubernetes. I think it's been said before in some way. I believe that Kubernetes is meant to be so complex and it's meant to be built on top of. So my hope is that this is one of many of the systems of its kind that are built on top of Kubernetes, just because we need more of this. We need more of these kinds of things, I think.
Yeah, I think so too. And I think it's great to see a project which, makes Kubernetes accessible to the broader developer population, because like you said, like, what's a developer, so yeah. it is good that, sorry.
Oh, you just reminded me of the Steve Ballmer, the meme. He goes, developers. Yeah. This just kind of reminded me of that. But yeah, that's exactly. What's the good question? What's the what is the definition of a developer? It's always tough.
Yeah. So this makes very advanced technology, which is very hard to well, to be honest, it's quite hard to get onboarded, even with the managed services. Mm-hmm. So yeah, that's really good. So if people, you said it is like will be available soon for people to get down.
Yeah. So that I'll put some links into Discord, but there is one repository that is basically read only at this point. So we built the alpha in there, and we're moving it over, making the code better, making the system more reliable, and moving it over into the KEDA core GitHub repository. So nothing in that repository works at the moment. I'm working off of the prototype code.
Can we see you work on that? Because you do live coding.
You can, yeah. I'll be doing some work on it. I think this Friday morning, my time, U.S. Pacific time. So you can see me work on it in person on Twitch if you want.
Cool.
I'll share all those links in Discord as well.
Yeah, cool.
But yeah, what I'll be working on is basically the operator that sits behind all of this, that coordinates creating all the resources or updating all the resources or deleting them, all of that good stuff. So yeah, the real version, the non-prototype version of this, we're aiming to have it done by the end of this month. So we can call it a beta, something, like an 0.1 or 0.5 or something like that. And at that point, it will be a lot easier for folks to come and contribute because there will be code to start from. But if you were really passionate about this, we would still love to have you now. Just reach out to me or file an issue in that repository, and we'll be happy to chat and help you get started.
Cool. And so I take it that by the end of the month, the community can also contribute to the project? Or
yep.
Okay. Cool.
Yeah, and folks can come now if they'd like. You just have to talk to one of us, and we'll help get you oriented because there's very little documentation at the moment. That's one of our big pushes, actually.
So you're especially looking for people who would want to help you with the documentation, probably.
Yes.
Good.
Absolutely.
Well,
yeah.
We know a few, so let's see if we can help you with that. Well, awesome. I'm so happy you are joining. One thing though, what I noticed is it's written in Rust.
Yeah, so we had written some of this in Rust. We're actually moving most of that to Go, and everything in the KEDA core repository will be in Go.
Okay.
There will be some additional pieces that are outside of the repository that probably will still be in Rust. And we'll be making it clear which parts are for this, which parts you need, which parts are over here. And this is all sort of in the name, this breaking up of all these components is all sort of in the name of the extensibility that I was talking about. And there are some cases where Rust is a better tool for that particular job. So you'll see some Rust, cloud native Rust. Yeah, it's fun. I've been learning Rust actually for this. It's really been really rewarding and fun.
How did you get to that point?
So one of my old teams at Microsoft, starting last year, they wrote a new kubelet implementation in Rust. And so they got me kind of turned on not only to Rust, but also to doing Rust in the Kubernetes world. That was very novel at the time. And I had never thought it was even a possibility. So they blazed the trail. I have immense respect for them. And I stole a little bit of their code to figure out if this is possible, and if I could learn it too, because Rust has that reputation. So after I kind of got a little prototype going, I wrote a CLI in it, and then at that point I became sort of more comfortable to write more. A lot of that is on a stream too, actually, if you want to see my struggles.
We can watch it back. That's great. Seeing a part of your journey. But I take it you with your years of experience, I can guess that coming from C++, that you made a journey anyways. You even programmed Cocoa, right?
Yeah. It wasn't the easiest thing. I'll be watching the Rust week, especially the AMA. I work with Ryan, and he's he's an exemplary engineer and an exemplary person too. But I know a lot of the work he does is sort of breaking down that barrier that some people have in their minds. Because Rust presents for me at least, I know a few others whose this is the case too. It prevents a really unique barrier to entry that it doesn't necessarily mean it's harder. It means that it's so different that you have to unlearn a lot of things that you've had in your mind if you were working with a previous language like Python or Go or even C and C++, honestly. All of that has different things that you've got to unlearn before you can kind of embrace Rust.
Well, I feel challenged right now to pick it up. Maybe.
You should
I can understand why you started. Yes.
You should try it.
Yeah. So I want to thank you very much for joining us here today. I'm so curious about where this project will go, and to get my hands on it as well, because it will save me a lot of time. So thank you so much for joining.